Oh, okay, okay. Like only for certain times the name things coming up. Okay, the recording has started, right? And how you all like the name of the class today? It was I think it was pretty clever.
Oh, yeah, I got the point of it because I was reading it. I was like, I don't understand. And then I was like, oh, okay, I understand.
All right, good. So, your waterfall is rigid, no going back. Evolutionary is iterative. The name is right at the top of the window, Alexa. The whole glass is not half full or half empty. It's twice as large as it needs to be. Alright? Yeah. So evolutionary is iterative and flexible. Okay? Flexible. Okay, so evolutionary is iterative, it's flexible. You're able to go back, you're able to revisit requirements. You could, of course, go around more than once. Whereas waterfall is rigid, there's no going back to previous stages, and it's not iterative. The waterfall model stays, once you have to get all the requirements and move forward and work with the requirements that you picked up in the last stage. All right. Um, what is meant by case tools? What is a case tools? What is a case tool? Sorry. All right. So a case tool is if we have to define the the acronym case tool, a case tool is a computer
It is software engineering.
right software engineering. Okay. So we have a computer aided software engineering tool. What does this mean? All right, this helps developers to create software, right? To create new software, right? Using software tools. So an example of a case tool would be something like an IDE, right? For program development. IDE for program development, bug tracking software for maintenance, maintaining software, um, not bug tracking software, right? So bug tracking software for maintaining software, right? Scheduling tools for analysis and, and design stages. Okay, things like yes, Alexa. No, Shavish, sorry.
Sorry, sa can I pop my hand?
Oh, you did it by mistake.
I was
All
I
right.
meant to
Yeah. You meant to what?
I meant to open the chat instead of tapping on the
Oh,
computer.
raise your hand. Okay. Okay. Right. Scheduling tools for analysis and design stages. Right. GUI builders for creating interfaces, etc. So those kind of things are keys tools. All right. We have a smart refrigerator. It's a refrigerator that can sense what items are stored in it by using the barcode of each item. So members of your household must scan each food item before placing it in the refrigerator. In this way, the item could be identified by its barcode The item could be identified by its barcode. The refrigerator file is then updated with the barcode details. When items in the refrigerator are used up, they are scanned again, and the refrigerator file is updated to note that the item no longer exists in the refrigerator. The weekly grocery report is generated, and a grocery list is automatically sent to the refrigerator to a by the refrigerator to a supermarket based on quantities remaining in the refrigerator file. The supermarket automatically takes payments from your family's bank account by sending the payment details to be processed, after which the account information and payment amount are sent to the bank. In the box provided, draw a level 1 DFD, right? So I'm going to open draw.io, and we're going to go through this. So just allow me to switch my to the window with draw.io. Okay, why is this site not loading? All right, I might have to use another. Oh, okay, right. So create new diagram. Okay, let's just go with a blank diagram. All right, everybody seeing the chat, the window, right?
Yes,
Everybody
sir.
seeing the window?
Yes, sir.
All right, good. All right. I just want to have the question open on the next slide here so that we could go through it. Okay, so we want to start off by identifying the external entities. What are the external entities? What are the external entities? Anybody?
Like the supermarket, like the grocery store. Grocery.
Right, okay, we have the grocery as an external entity, yes. Right. Who else is an external entity? What would be like the first external entity you might think about? So you could identify the supermarket. Okay. What else? Who else?
Like the family member.
Right. Yeah, a family member. Right. So a family member. Okay, because that's the first thing that they said. Members of the household must scan each food item before placing it in the refrigerator, right? And if we have to take a look at the, any other entities there? Right? We may or may not have the bank, depending on how people implemented it. Let's put the supermarket to the side there and just take it step by step. Okay? Right. So we have the family member, and the first thing that we could do is that we say members of the household must scan each food item before placing it in the refrigerator. Right? So that's some kind of that's kind of like an item registration, not so? We could call that one item registration. Okay, so we have the family member doing what with the food item? They're scanning in the food item. So, oops. Right. So we have that food item coming into here, and right, item information. So we put that item information inside of the, pass it along, and we register the information into the fridge. So when you bring your groceries home, all of the groceries, everything that you're putting into the fridge, you will scan it and etc. Right? In this way, the item can be identified by its barcode. The refrigerator file is updated. So we have a refrigerator file, right? This is our D1 fridge file. And we want this to update information. So we're going to say, okay, right, item update. Okay, because we just added information into the fridge file. And the refrigerator file is uploaded with the, or we could even say item barcode update, right? But we know what we're talking about. When items in the refrigerator are used up, they are scanned again, and the refrigerator file is updated to know that the item no longer exists in the refrigerator, right? So some of you all, what you did was that no, Collins, you might not have been wrong, right? Some of you all, what you did was that you had this item registration and then you had this item removal, or some of you all merged this into one process. Okay, I'm going to put it as two processes. So the first one was item registration. Then we have two item removal. Okay, and we see here, okay, item to be removed. Okay, and what we do is that we update this fridge file as well with, of course, item update. Okay, so you could have merged it into one, or you could have had it one or two. That's fine. All right. Some of you all did this across two, some of you all did it in the same one. That's fine. Okay, they are scanned again, and the refrigerator file is updated to know that the item no longer exists. Your weekly grocery report is generated, and a grocery list is automatically sent by the refrigerator. Okay, so we have the weekly grocery report happening here. I feel like I'm going to run out of space here. Good. Okay, so we have another process here. That is the third process, which is your grocery report. Weekly grocery report generation. Okay, so we have our weekly grocery report generation process. And where does this weekly generation grocery report information have to come from? It has to come from, okay, request. We have to request, of course, information. So, details request, and then we have our, we have our grocery items. Grocery item status. So we could take the information from the fridge file, right? We could take information from the fridge file, and we could update our grocery items status based on the weekly grocery report. And that list is automatically sent by the refrigerator to a supermarket based on quantities. So we have our grocery list here. We have our grocery list here. And then when we have our grocery list, and a grocery list is automatically sent, the supermarket automatically takes payment from the family bank account. So we have a payment processing aspect here. Okay, so we have a process. All right. Grocery payment processing. And what I would like to note is that this here, information inside here, should have come from the family member as well. So we should have a little bit of data from the family member being all right, banking credentials. So the family member or somebody who owns the refrigerator would have to put our banking credentials into the fridge. Okay, and then we have the grocery payment processing. What they say, the supermarket takes payment from your family's bank account by sending the payment details to be processed, after which the account information and payment amount are sent to the bank. So your supermarket is going to send information on the supermarket will send information on the what? All right, let me. All right, bill for grocery items would be sent to the payment processing process. The grocery payment processing process would take the bill, and what would happen? The amount, after which account information and payment are sent to the bank. So we have an external entity being the bank. And some of you all, I noticed you all broke the rules of DFDs by having a direct relationship between the supermarket and the bank. But if it is that the supermarket and the bank had its own thing going on, we cannot reflect that in this diagram. But because it's passing through this grocery payment processing process, which is something that the fridge did, right? The family put in their banking credentials so that when we get the bill for the grocery items, which should have come as an arrow. Okay, yes. This arrow, right, pointing to here. Okay, so when the bill comes from the grocery into the payment processing, we're going to send some information to the bank. We're going to send some information to the bank. What information are we going to send to the bank? All right, we're going to send the what do you call it? Let me take a look at the shoot. Right, let me take a look at this here. Right, what is it that we sending to the bank? We're sending receive payment and account information. And the bank, of course, will send back some sort of confirmation to the payment processing, right? Confirmation of payment. Or it could send back a denial of payment or whatever, right? We could make the assumption that this information will be sent back as some sort of confirmation to the supermarket. Sorry, excuse. Right? So confirmation of payment. And of course, the family should get some sort of receipt of payment from the family should get some sort of receipt of payment from the payment processing system as well. Okay, so we have receipt of payment. And so this is complete in terms of the entire system. Okay, it's not too complicated. It's 4 processes. We have 3 external entities, and in some instances, a couple of assumptions that we make there. Okay, you could draw it and label it in pencil. Just make sure that your pencil is dark enough so that people, whoever the invigilator is, could read it. Okay. Ah, sorry. Yeah, Collins, did I put the word data there somewhere, or is it something that you were just sharing with the class? Collins, you hear me? Hello? Oh, you were just stating. Okay, understood. All right, so we could agree on this. Anybody has any issues with this? Anyone has any issues with this solution for the DFD?
No, sir.
Seems good. Once you have something close to this or reasonable like this, right? As I said, some of you all did the item registration and the item removal in the same process. That's fine. Okay, so you could have had like an item add remove, and you asked the family member would have said, okay, item to be added, item to be removed. And in both cases, that one process would do an item update. So that's fine, right? Once you have the grocery item inside there, the grocery list being sent to the supermarket, then you okay, yeah. You have the grocery list items being sent to the supermarket, the bill for the grocery items coming back, and then the payment processing going on. Okay, this banking credentials is more of an assumption than anything else. They didn't explicitly state it. But at some point you would have had to put in your banking credentials into the fridge so that the bank could know where the account information coming from. And the receipt and the confirmation of payment, again, those are assumptions too. Those kind of like close off the DFD. It shows, okay, this is where we could get the bills tracked. All right, so that was the justification for those. Define the following terms and provide one example of each to support your answer. So what is a functional requirement? Okay, a functional requirement is, and some of you all put things like it's required for the program to function or work properly. That's not really, true, or it's not the ideal, right? A functional requirement is a feature of the software that satisfies the customer's needs or business rules. So when we say that, what do we mean? We would mean that a payroll processing software should be able to calculate NIS and PAYE values for employees from a certain organization. All right. So if it is that you have payroll processing software, the payroll processing software should be able to manage things like NIS and PAYE calculations, etc. You're not just saying how much, how much hours the person work, how much the gross salary is. It should be able to calculate things to be able to allow them to figure out the net salary as well. Okay, so like a non-functional requirement is a feature that does not impact or relate to the rules of the business, but adds value to the software for the customer. Okay, so a feature that does not impact or relate to rules of the business but adds value or software to the customer. This would be like something like, let's say we have that same payroll processing software that allows for data to be sorted by name, date of employment, or let's say salary ranges. Now, something like that is not necessarily going to impact the operation of the core feature of that software, which is payroll processing, working out how much people get paid, salary, right? All right, working out how much people get paid. But at the same time, it's good because, say for instance, you want certain reports done, etc. This is an extra feature that makes it easy for the people using the software to not have to export data and then probably use Excel or some other raw data format to be able to stratify the data as they like. Everybody's fine with this?
Yes, sir.
Good. All right, so we have Rebill. Rebill is a company with several employees, personal details such as name, address, telephone number, as well as a unique ID for each employee are stored in the employee database, considering the employee ID attribute in the data dictionary. So we're looking at the employee ID attribute. State what the description, attribute type, length, and range elements stored for this attribute. So what is the description of the employee ID? The employee ID allows or is a unique number that is assigned to each employee. Okay, what's the data type of this? So you could have chosen your type, right? Your data type for this could be an integer. Okay, and if it is that your length is, let's say you could have put for length, it could have been a 32-bit number. All right, and then you could specify the range. So the range could have between 11111111 to 8999999. Right? And so every employee would have a number that is somewhere between 1111 and 8999999. Once you had something like that, it's basically, that's your answer right there. Okay. If it is that you had, let's say, some sort of string value, right? If it is that you had a string value, let's say your data type was string, okay? Because maybe you had a length. What you could have had is that you could have had a length of 4 characters to 6 characters, okay? And let's say your range, if you wanted to specify a range for a string, you could have done something like A to Z, right? 999, sorry, 111 to A to Z, A to Z, 99999. Something like that would have also worked. So what this tells me is that, your range would be like a 1 alphabetic character starting from 111 to an alphabetic character going up to 9,999. Okay, so either one of these, let me draw a line in the middle here to specify that these are 2 separate things, could have worked. Any questions? Any questions?
No, sir.
All right. All right. So we have alpha testing and beta testing. Alpha testing is, okay, in-house testing. Okay, alpha testing is in-house testing done by the developers of the system while they are building the system. And beta testing is, right, kind of like user testing to get information on how the software handles in real world scenarios, right? This software is still considered pre-release. Okay, so it's pre-release software. It's not the actual software, but we want to get a real-world testing scenario of it because there's only so much test data that a developer could feed into a system. Okay, there's only so much data that a developer could feed into the system. But people out there using the system would use it under different configurations than the developers would have. The developers may put in different software configurations or data configurations, but have it on ideal software or ideal hardware, sorry. Whereas beta testing, you allow persons to download the software, use it on whatever hardware they have. The hardware might not meet exact requirements. The hardware might be far surpassing the requirements. There's no way that the alpha testers could test every possible scenario. So the beta testing allows for the developers to get to collect data in real world scenarios, or as it would be used on somebody's computer. All right, so we had this one. A certain university has several departments. Each department has a unique name associated with it, right? Each department offers courses with distinct names, each of which is taught by a single professor and one or more teaching assistants. This one, I was a little surprised that some people had issues with this question, right? First of all, we don't represent the university because the university owns the database. The university, there's only one of the university. So there is no need to represent the university as an entity. Okay, so our university has several, we start off with departments. So our university has several departments. Each department has a unique name. So name is an attribute, right? Each department offers courses with distinct names. So we have courses, a course, and a course has a name. And that distinct name tells us that this is the unique identifier, right? The relationship between department and courses or course is that a department offers a course. How much courses could a department offer? They could offer many courses. What's the least amount of courses a department might offer? One course. A course is offered by one and only one department. Everybody with me so far? Yes? No?
Yes, sir.
Right. So we have each course is taught by a single professor, right? And one or more teaching assistants. So let's say prof for professor, right? We say taught by. So a course is taught by a single professor, right? And one or more teaching assistants. So a course is taught by one and only one professor. But a professor could teach how many, what's the most amount of courses a professor could teach? A professor could teach many courses, not so? What's the least amount that a professor could teach? We could assume that there are times where a professor mightn't teach any courses. So a professor could teach 0 or more courses. Okay, but one or more courses would also be acceptable here. That's according to the system. All right. And then the course would have one or more teaching assistants. So you have a TA as well. Right? A course has one or more teaching assistants. But a course would have at the very least one teaching assistant, but it could have more teaching assistants. A teaching assistant could teach one or more courses. So this is what we ended up with here, right? That the department offers a course. A course has a teaching assistant, one or more. A teaching assistant has one or more courses that they work with. A course has one professor. A professor teaches 0 more courses. Okay? Everybody's fine with this? Yeah,
Yes,
I
sir.
know. I saw Shania. Okay, I saw that. I didn't really too much agree with that because it's not really the teaching assistant for the professor. The teaching assistant is for the course. So, All right. So it's 2 o'clock. Let me give a 10-minute break, and then we'll come back and we'll do either questions 1 and 2 or 5 and 6, depending on what you guys choose. Which one you all want to do? 5 and 6 or 1 and 2?
5 and 6, please.
5 and 6. Okay, no problem.